wondering what you're doing here. This, in hundreds of years to come, people will look in books and wonder who these people were who sat here and listened to this, because this moment in history is when humanity changes forever, and it never goes back. Now, how can I say that? How can somebody be so sure and say something that sounds so ridiculous? Well, this is why you're here. Because if I go to a university or a newspaper and say that, they won't listen. They'll throw me out. There's one university that did listen. A small university, Hull University, where I lived in England. And I showed them the work, and they looked, and they knew something was happening. They said, come back when you've finished. If I send the work to Oxford University, nobody opens it. I've already broken the rules. They told me, you can't do that. You're breaking the protocol. You're breaking the rules. But if I can write the theory of everything, I can write the rules. That's why you are sitting here, and this is not happening in Oxford University, because this school allowed this to happen. So let's go on a journey. This journey started 25 years ago when I decided to do this, hydrogen to human. Logic, and the logic of this is ruthless, says if you just have hydrogen out there in the universe, nothing else, it starts to self-assemble, and it keeps going and going, up a complexity gradient, up and up and up, until it gets to the human brain. That's the most complex thing in the whole universe. There's nothing more complex. And then something really special must happen. That brain, one day, has to start to understand itself. Now, the brain is part of the universe. So when that happens, we can say the universe understands itself. Now, that sounds very difficult. It takes a while for you to process that information. But that's what's happening here today. The universe is starting to understand itself. Now, we haven't been able to do that because there is no evolutionary advantage to knowing what you are doing. You just do it. Animals don't need to know what they are doing. So if we look in the history books, all we see is chaos. It's a mess. And now I'm going to show you how that mess comes to an end. So let's go on this journey. A journey through cruelty, complexity, and pianos. There's nothing in the universe except the four forces of nature, the rules of matter. Ooh, lost it. Yeah. When they get into relationships, they make something out of nothing. Hydrogen is not a thing. If we look at the words, nothing, no thing. It's just electrical charges. It's not a thing. If you think of the elements, think of gold and then carbon. They're completely different, but they're both just made of electrical charges, nothing else. So their different properties don't come from the electrical charges. They come from the relationships between the electrical charges. The universe is not made of atoms. That was stated by Richard Feynman, one of the world's greatest geniuses, and he was wrong. The universe is made of relationships between forces. That's it. There is no substance to anything. When you look through a window, you're not shocked that you're looking through a solid object, but you should be. If you grow up with something, nothing shocks you. But when you look through that window, you know there is no thing there, nothing. So how do you make something out of nothing? Simple. If I've got two nothings, which are different, and they must be very, very different. Gravity. Nothing number one. A pathetic, weak nothing, and it must be. And electromagnetism. Nothing number two. A quantized. That means it comes in exact amounts. There is nothing more precise in the universe than the precision of atoms. Quantized amounts, mathematical amounts. Gravity, not mathematical amounts. It's an analog system. But if gravity pulls together charges that repel, when they get close enough, they stop and makes something out of nothing. Now what's actually happening is, if there is asymmetry amongst the charges, they start to distort space. Just like putting a heavy ball onto a bed. It bends, and everything else on the bed will fall down to the ball. The fabric of space, what we now call the Higgs field, that's what distorts. So this is what nothing looks like. Now there are some things here. The stars. But the background, that's hydrogen. So just think of it as the first thing that self-assembles anywhere in the universe. H2. Why is it H2? This is the sort of information that is not in the science books. You always see O2, H2. Why? Nobody tells you. You can't have oxygen or hydrogen by itself. Because it's like a piece of sticky tape. It sticks to things. And if I have a piece of sticky tape, dust will stick to it until it stops being sticky. But if I get my sticky tape and stick it to itself, now it's not sticky anymore. It's found a mathematical equilibrium. So we're going to start there on our journey with hydrogen self-assembling into H2, the first molecule. That's what it looks like. So I've just got a symmetry in space, the Higgs field, a flatness, a void, just full of these. They are not things. They're just a little place where some energy resides. If it starts to fall together, just think of the heavy ball on the bed. Once it starts to go, it gets to a certain point where it just all gets bigger and bigger and bigger, and it can't stop. Now those points where something changes, we know the mathematics of where that happens. They're called Feigenbaum points. And the Earth is approaching a Feigenbaum number right now. And that number determines when the climate reaches a point where it goes into a feedback loop and never comes back. So I can say the climate change is not just the biggest problem that looms for all of us. It is our doom. Once we go past that number, the system changes and it never goes back. It's like trying to stop a typhoon from forming. It's impossible. And nobody can argue with me. Because if you can't do the mathematics, you have to shut up and listen. So this is what forms. Now the fire that's coming out. A little boy said to me yesterday in the class, why is there fire coming out? The energy that comes out of here. And again, if you look in the books for children, it's not there. It's in the physics books when they're at university, but that's too late. We teach here what other people learn in universities, and we teach that to children who are 7 years old. No problem. That fire comes from another nothing. The strong and the weak nuclear force. If I use gravity to pull together particles, and that word I really don't like. It pulls them together so close that they stop. But if it gets bigger and bigger and bigger, I get more and more and more gravity. Until one day, the universe lights up. If two particles get close enough, the strong nuclear force grabs them. And that releases energy. That's the energy that comes out of atomic bombs. So it's simply that. Now that is the biggest object in the universe. So it is a relationship between the two forces which have the biggest difference between them. Gravity and the strong nuclear force. That's what it is. That's what a star is. And planets simply are not big enough to push together two protons using gravity. So they stay apart. That's the difference between a star and a planet. A planet is a relationship between two forces, but not the strong nuclear force, the electromagnetic force, holding that planet up. And if I have a small object like a rock, I need two nothings to make that something. And that is a nothing which is its own similar opposites, electromagnetism. It attracts and repels at the same time, so it can make all this stuff. And by the way, everything that you can see around you and the earth is an illusion that's made in your brain, and you project it out around you. The next time you look in the mirror and you see that depth in the mirror, it's a perfect illusion. And you create that illusion inside your head due to the interaction with the light which is interacting with all these particles. And this is you must use that particular energy level of light, because that is the energy level at which light will interact with all this. If I use a different energy level, there's no interaction takes place. I see nothing. All this here now, the air, there's no interaction taking place, so I see nothing. If you could see in microwaves, it's useless. What you would see is this. Nothing. Absolutely nothing. So that illusion that we project out is inside here. And that's a very, very important step to take in your life, when you realize that this illusion is just something inside your head. It is not out here. It's a picture. At the middle of the star, the complexity of the universe is starting to increase, because the star is putting together more and more and more protons. But it's getting harder and harder and harder, because the more positive energy I put together, it's harder to put another one in. Every time it gets more and more difficult. And then one day, as we start to make these, we get to iron. And when you put that last proton in and make iron, the process stops. The energy holding that star up balanced against the gravity pulling it together. Suddenly it's switched off. So what happens? The star just collapses and the material comes together almost the speed of light, and then it hits in the middle and just comes out. That's a supernova. And all this comes out. And now I've got a very different universe. I haven't just got hydrogen. I've got all this to play with. And this is going to start to order and structure itself. It starts to make patterns. Now, patterns denote meaning. They're telling you something. These patterns self-assemble. The pattern dominates each picture. The details are all different. Now, why haven't people looked at this before and said, oh, isn't that interesting? Look at them. It's obvious. But there's part of the human condition that means you cannot see the obvious. What is right in front of your face every day, you can't see. That's part of the human condition. And it's that condition which leads to wars, famines, and stupidity. It's that condition which allows us to race towards the cliff of climate change. But this lecture will bring that to a halt. Now it's this picture here, and Gracie will remember this, when I was giving a little lecture, and I suddenly realised that this pattern here would hold the clue as to how the solar system assembles itself from rocks and rubble and ice, just a mess, chaotic, into a clock. The solar system changes into a clock. How can rubble floating in space change itself into a clock? That clock counts the solar system, not the other way around. Now, if you look at this, if you open books, you get the names, and that's what we teach the children. The names have no meaning. The pattern is not in any book, and it's completely obvious. There's 4 small heavy ones close into the sun, all made of rock and metal and water, high density. There's 4 big ones, all low density. They all have rings, and they all have many moons. It's a pattern. The small, high density spheres close in to a large, low density sphere. And that means the sun must have rings. Why isn't that in any book? Because the obvious is what you miss. It's called the asteroid belt. And it's obvious where it goes. It goes in between the small heavy ones and the big light ones. It's obvious. And it must have gaps, just the same as the rings of Saturn. And it does. They're called the Kirkwood gaps. Now, if you show children the pattern, it all has meaning. It adds up in their head to something that makes sense. But how does it make itself from rubble into a clock? Elements, they've got many different masses. There's heavy ones and light ones. So it's going to start to order itself due to those different masses. It's going to put things where they have to go, where it's balanced. The Earth sitting in a special place, balanced between the gravitational pull of Saturn pulling this way and the Sun pulling that way. These points are called Lagrange points. Nobody's ever heard of them. but you can teach it to children who are 7. The sun must be the dominant player. It must be the biggest thing to control the clock. That's going to start it working. And we're going to get cycles, orbits. Now, gravity doesn't have an opposite partner that's going to allow that to happen. So it needs to go into an equilibrium with something called the conservation of angular momentum. It's using a different thing to make a partnership. And that's going to make things go into an orbit. As the planets have to turn on a tighter and tighter orbit, as they get pulled in towards the sun, they have to spin around. They can't slow down, so they have to go around twice instead of once, so it goes faster and faster. But then, when you accelerate something through the Higgs field, something that has mass, it has a relationship with the Higgs field. It doesn't want to turn around, so it gets to a point where it balances and stops, and that puts it into an orbit. Now this equation, this is what Isaac Newton could not do. He gave up. Something else which is not in a book is the fact that Newton's work, classical mechanics, here it is. This book here, endless pages of nonsense. It's not nonsense, but if you can't understand it, it might as well be nonsense. This doesn't work for more than 2 bodies in space. So the Earth and the Moon, that's this. The rest of it doesn't work, and that is not in this book, the fact that it doesn't work. The solar system is not in that book. Isaac Newton said, this must be the work of God. He invokes intelligent design, gives up. Can't be done. But 200 years later, a French mathematician called Laplace comes along. And he nails it with that. Oh, sorry, Bessie, can we go back to the equation? Thank you. Now, what you see with this equation, here, a minus sign. That means there's a difference between 2 things. And here, F1, that's F0. So this is an iterative equation. It just keeps, you keep putting the answer back into the equation and it just keeps going round and round. Now what this is when something's in an orbit, there's a relationship between all the parts. Relativity, a relationship. It was telling you that all along. As something orbits, if there's 2 more bodies, it'll slow that one down and speed this one up until it gets into an equilibrium. So that minus just gets smaller and smaller and smaller until it doesn't matter. Now, this is the important bit. What I realized looking at this equation is that this equation is going to bring peace to the earth. How can I say that? How do I know that? Because people behave exactly the same as atoms. Their behavior is quantum. We behave statistically. Atoms behave statistically. How remarkable is that? If you have a city and the crime rate is 12%, the next year, what will the crime rate be if the social situation doesn't change? Now you can all answer that question yourselves. It stays the same. A different group of people, but 12% commit the crime. So I can say that this is the equation that changes everything. And if you look at the bottom, it says chaotic to stable. Now let's have a look at the mathematics that does work for the solar system. Here, this book, I started reading this book 25 years ago. It is the most boring, badly written, load of nonsense. It's advanced nonsense, but when you first read it, you can't understand anything. Chaos and non-linear dynamics. Most of us don't know what that means. I know what it means now. It's the behavior of systems, complex things. The Earth and the Moon are not a system, they're a duality, just two. This is the behavior of systems. And what I noticed looking in this book is that the behavior of an electrical circuit that goes into chaos and an ecosystem, a relationship between a predator and a prey, produce the same mathematics because they're both systems. The systems change at exact points. It flips over from this into that, a different system. So what is going to happen on the earth today is that we, you, take this information away from here and give it to newspapers, your friends, TV. If I go and tell the TV, I can do this, they won't believe me, but they will listen to you. And what's going to happen? Exactly the same thing that happens with the solar system. It gets to a point where it flips over from chaotic behavior into stable behavior. And that's what's going to happen to the human race. Because when you learn today how people work and you understand yourself, you start to understand what's happening around you. And it's a remarkable change that takes place in your head. People behave to a very simple set of rules. Everybody has a different mix of the same chemicals. So it looks as if everybody's different, but we're not. If you provoke people, they start to react. Some people react first, but everybody reacts in the end. What we call criminals are people who react to a situation first. They get the biggest reaction. But in the end, everybody reacts. The people like Nelson Mandela and Aung San Suu Kyi, they're the last people to react. And we all admire them subconsciously. We don't know why, but that's the reason why. So there's my behavior of systems. Here's classical behavior. And there's one more kind of behavior. Quantum behavior. It's so strange. This behavior here, when you take a particle, and that's the wrong word, it's not, that makes it sound like it's a small ball of substance, it's not. If you shoot that particle at two slits, it goes through both of them. And that was such a shocking truth for the people who first discovered it, that Erwin Schrödinger, who wrote an equation that described that behavior, said he wished he had nothing to do with it. Because that brings a problem into physics. This behavior and the behavior of this are in different books because they don't go together. Here's the problem. It's called the measurement problem in physics, and it's the biggest problem in all of science. This behavior, gravitational behavior, general relativity. This behavior, that equation is called the wave equation, quantum mechanics. This is how subatomic particles behave. And there is no relationship whatsoever between this and this. That is a contradiction. You cannot have a contradiction in science. You cannot. The universe cannot contradict itself. So what do? We ignore it. We hide it. That's what people always do when they don't understand. So I thought, well, this needs sorting out. Somebody needs to solve this problem. You can't have contradictions in physics. But if you say the universe is made of atoms, that is a mistake. It's an obvious mistake. The universe is made of relationships. As soon as you say that, there's a relationship between two. And you must have two. You can't have one. You can't have a relationship with one thing and nothing else. And they must be completely opposite. If you look at these, they are dissimilar opposites. And that's very important. We're going to see later. If I look at patterns like this, what I see is that they are mathematical. Quantized. Atoms are mathematics. That's what mathematics is. It's amounts, exact amounts, precise amounts. I see 6. I don't see 6.2 or anything like that. I see precise amounts. And that mathematics is coming out of the atoms which are making this. The details you'll see are all different. You must have a small amount of detail which can be different, or there is no change in the universe. If I look at helium atom, it's perfectly balanced. Can't stick to anything. It is inert. It is dead. You must have a small amount of flexibility. You must not have complete equilibrium. It's that asymmetry which creates change. If I look at these patterns, I see symmetry coming out of the atoms. It's not, we teach that as in books that people produce symmetry. We don't produce symmetry. It's coming at us, out of the universe. It's talking to us. But until now, nobody's been listening. Now this is the Mandelbrot set. And you can see the symmetry. It's got a head and a tail. It's got left and right. The head and the tail are created by the left and right. Left and right are created by the head and the tail. Two dissimilar opposites and two similar opposites. Now that's a theme that's going to be repeated again and again through the universe. This is produced when you put an equation into a computer and you feed the answer of the equation back into the beginning. You use complex numbers. So there's an amount of change. And it just keeps producing these patterns endlessly. It just does this. It just keeps on and on and on, infinitely producing the same kind of patterns. But what happens is that Mandelbrot set keeps coming back. You can see it here, there. And this is the edge of the Mandelbrot set here. There's another one. There's another one. The detail of the patterns just keeps changing. Now this, very strangely, when your brain has enough information and it starts to connect up the information yourself. I vividly remember lying in bed, 3 o'clock one morning. My brain starts to do that because it's connecting the information up. And I'm hanging onto the bed thinking, oh God, this is wonderful. I love this. It was just one of those moments when you know that something really important is taking place inside your head. It's happened twice. Probably won't happen again, I don't care. But one day, everybody will have that experience. You get to a point where you have enough information inside your head, the circuits will fire by themselves. That's not happening on the earth now. It's a mess. We teach this, 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 and this, and there's no relationship between them. That nonsense is just about to stop. The quantum world can only start to